All right. Hello, everyone. Good evening. I hope you can hear my voice loud and clear. I'm sorry about the echo. I had to close the window so that we can shut out every noise. You're welcome to today's webinar. As you all know, at Red Tea, we try to engage more solar entrepreneurs through webinars that address subject matters, which are areas where they are having difficulty in their journey as entrepreneurs and to establish their own business or to try to work for solar companies. So that was why we started with the free webinars, and we've gotten a lot of positive feedback from young people like you. Today, we're going to go really fast and we're going to have this webinar titled How to Do It Yourself, How to Size Your Battery, Inverter, Charge Controller, and Solar Panel. We get it every time, people calling us, hello, how do I know how many panels for my 3 bedroom flat? How do I know how many panels for a 1 kVA system, right? So that is really at the basis of your work as solar entrepreneurs. And today we have one of our engineers joining us. She's a young lady who have done us very proud in the field, right? Because she's really, really doing a good job. And today she will be taking us on this course. So right away, I will go ahead to introduce Engineer Enobong. Can you share your screen now? She's going to share her screen and she's going to start off the webinar. Miss Enobong is also she's one of our engineers at RETI, helping to support and advise on a subject matter for engaging our alumni and for engaging our students. So today we're all going to be learning from her. Are you still here, Enobong? Hello?
Hi, yes, I'm here.
Okay, please share your screen now. I think your time, feel free to start. So when you share your screen, you can then introduce yourself and you can start. Thank you.
All right.
So I'll stop sharing my screen, sorry, so that you can share yours. Yes. Okay, you can share yours now.
All right. Hi, everyone. Good evening. My name is Enobong. A facilitator with Rexy. This is my first, so this is going to be my first webinar. So I want to know if everyone can hear me.
You can indicate the chat box if you can hear her. I can.
Okay, so can we have people just respond in the chat box so I'm not talking to myself?
Hello, good evening, everyone. I can hear you.
No, great.
I can hear you as well, so you can shoot.
Oh, all right. Okay, so today I'll be talking about DIY. I titled DIY battery inverter and solar charge controller sizing. So I've noticed that this is where there's so much lapses in the solar industry, where people do not stick to, or installers do not stick to basic engineering requirements or standard. So here's just a simple guide, a DIY, a beginner's guide to PV sizing. Yeah, so here we have about RETI, what we do at RETI, the trainings we have, and the alumni as well, and the fact that we are trying to very much encourage solar entrepreneurship in Nigeria.
Can you increase your voice a little bit? Sorry.
Oh,
Yes, please.
is that clear now?
It's a little bit better now. Maybe you can put your mouth closer to wherever the sensor is.
Okay.
Better now.
All right. All right. Okay. So the content of this webinar: how to size panel. Yeah. Then types of charge controllers and their working principle. We have load profile and inverter size calculation, battery sizing, PV system sizing, and balance of system and protection. So at the end of this webinar, it's expected that everyone that has participated should learn how to size a PV system, what it means when a system is imbalanced, or what it means when a system is balanced, when an inverter installation is balanced. And this is also to create interest in standard installation practices. Okay, so this is just an overview of what PV models look like and what they actually do. So I have here that if you look at the solar panel, you'll see that they are divided into different segments. So we have them divided into cells, then we have them divided them into modules, and we have panels in 60 and 72. So actually, really, if you are new in the solar system business, is important that when you go to purchase your solar panels, you should actually like count. You can see like the patches of, so you are going to have five, it's usually like 5 by 12, that's 60, or 12 by 6, which is 72. So that is when you know that yes, this panel is actually what they say it is. So I have here that a group of solar panels, what you see on the rooftop, or what is you see as a complete installation, once it's beyond one solar panel, we call that a solar array. So I have here that the solar modules, they capture the sun ray that strikes, and what we have at the endpoint generated as electricity is DC, which we can't actually use in states. And based on how the sun, it's not um it's not steady, like it doesn't shine completely for a very long hour. You don't have the sunlight steady. Sometimes it's up, sometimes it's down. The sun is hot now, and then another time it goes off, or it goes down. So because of how unsteady the sun is and solar irradiation is, it's always best to, yes, hook up our system to a charge controller. That's what I mean by we can't use this system. That's what I mean by we can't use this system directly. It definitely has to pass through other devices, and these entire devices is what we call the balance of systems. So the balance of system includes the wiring, the charge controllers, the inverters, the storage, and definitely the PV, I mean the protective devices. Hold, sorry, I just have to pause till everyone can hear me better.
No, the voice is a little bit shaky. I wonder why. I think it might be network problem. But you're trying to
Um,
keep very close to the sensor, right?
so, so I'm really, really close to my headphone.
It sounded
So,
very clear right now as you're speaking now.
okay, probably I'll just speak slowly so
Mm,
everyone can get me.
yes. Just speak
So,
because you're speaking before, but as loud as you can, please. Thank you so much. Don't worry about
okay,
the chats. I will handle that. Just focus on the webinar. Thank you.
all right. Okay. So, as I said earlier on, we can't use the electricity that is directly harvested by the solar panel. Reason being that the solar radiation fluctuates. So by 8 o'clock, sometimes it's sunny, sometimes it's not sunny. By 9 o'clock, it might be sunny. Before you know it, becomes cloudy. So these are the reasons why, or this is the reason why we can't use the electricity from the panels directly. What I mean by that is we can't wire our panels directly to we can't wire our panels directly to our devices. So definitely we have to pass them through other devices, which we call the balance of systems. So these components are the charge controllers, the inverters, the storage, and our protective devices. Okay, sorry. So here, this is load analysis. And here we're going to treat a little home. Oh, I'm so sorry, my voice, you can't hear me. This is my loudest. I'm sorry, guys. You can't. For those that can't hear me clearly, I'm really sorry. I'm using a Bluetooth speak microphone, so I don't know why you're not hearing me properly.
Yes.
Okay.
Just go on. Just go on. We would see what to do about that. Just go on.
Okay. So inverters are bidirectional power electronic devices. What that means is they can work as AC, and they can also work with DC power supply. So for the AC power supply, the inverters convert it to DC, while for the DC power supply, the inverters invert it to AC. So that's where we have the inverter phrase. You can see that sometimes you see devices. We have a device called, or an electronic device called, a PV inverter. So what that does is that it converts directly from the solar panels to it converts the DC power directly to AC, or it inverts rather. So and when we're moving from DC to AC, we call it inversion. When we're moving from AC to DC, we call it conversion. Okay, so the inverters are usually wired to the battery, and they are wired to the battery and also to an AC source. So the AC source supplies the AC power that's going to be converted to DC, while the DC source, which is usually a battery, co- um, converts from the allows the inverter to convert the DC to the AC. Sorry about the mix-up. So inverters, mostly what we have in the market, inverters are mostly rated in kVAs. Yes, you find kilowatts inverters, but conventionally and industry standard kind of, we have them in kVAs. So when an inverter,
Oh, God.
hi.
Don't worry about that. Go on. Everyone, please switch off your microphones. Thank you. Continue, please.
Okay, so when designing an inverter, it's very important to consider the load profile of your client or your house where you want the inverter system to power. It doesn't make sense to say you want a 3 kVA inverter when you don't know what loads you'll be powering. So down here in this table, I have a sample home. These are the loads the inverter will be powering in the home, and you can see here that I have taken time to tabulate the appliances, the quantity, its wattage, the total, and also considered power factor, because the inverter in which I want to use is going to be in kVA. So I have we have a light bulb. We have 10 units of light bulbs. We have TV. There's a TV. There are two TVs, one fridge, two laptops, and the wattage of each of these electronics is considered. So the light bulbs are 15 watts each. The television is 500 watts each. The fridge is a 1000 watts fridge. Laptop is 70 watts. So tabulating this, the total wattage here is the summation of all of these loads, and that brings it up to 2.2, or I can say 2.3 kilowatts. And then converting that to kVA, I have it here as 3.1 kVA. So
Okay, I guess that is network issue. Right now, what she's trying to share about is like how to determine your total load in sizing a system. So I'm going to just hold this on until she comes back online. As you can see on the screen, before you can size a system, you have to conduct what we call an energy audit for the household that you're trying to work with. Okay, I think she's trying to come back online. So what just happened there was that the engineer has outlined all the appliances that they want to power, that the client wants to put on solar. So now you have the TV, you have an electric kettle. I can't remember what she had on the screen then. So you had all those things and you're meant to get the total wattage. Good. So yes. Are you back now? Hi, Nobong. Yes, so we would wait for her to put it all together. Okay, good. Okay, yes, so you can continue now.
Okay. So what I said last was to carry out a load analysis of the home in which you want to power. So to retrace, I have this home, and these are the quantities and the wattages of all the appliances this home has. Mind you, where I have this power factor, where I have the power factor here, it's not really necessary that you look for the power factor of all of these devices. What you can do is assume a 0.8, which is apparently what we use, which is what is used, I think is a world standard conversion factor. So we have 0.8 as usually the power factor of most of our devices here in Nigeria. So you could assume 0.8 for all of these appliances rather than looking for the power factor of each of the appliances. So what we have here as our total kVA is 3.1, and we don't have a 3.1 kVA system in the market. So it's just best that we get what is closest to this value. From 3.1, you're not expected to go for a 2 kilowatt. It won't make sense to do that. Rather, you should size ahead. So if your total load gives you 3.1, it will make much more sense to get a 3.5. And this would also give tolerance for conversion losses as well. So moving on to the next, which is our battery sizing. So our batteries are actually connected in between the solar and the inverter. So what the battery does is the battery serves as a storage for our inverter system. Without the battery, you can't have a stable system. Your system is definitely unbalanced. So I hear people say they want inverter and they forget that the battery is a major component of the inverter system. So yes, most definitely you need battery to supply the DC and also to save the energy that has been harvested. So I have here that our batteries are rated in amp hours, and definitely to allow your batteries last longer and to serve its purpose and to save the time and the money to make more financial sense, it's best you don't discharge your batteries beyond 50% depth of discharge or state of charge. So the state of charge is what your current battery is doing, or what the current battery charge you have. So that is what state of charge means. While depth of discharge is actually at what range are you discharging your batteries. So so you can wire your batteries in series or in parallel depending on your inverter system. What that means is that the inverter determines how you wire your battery. If you buy a 2 kVA inverter, you would see behind is going to be specified the DC input voltage will be specified. It will be written on the back of the inverter. So with that, you can know the number of batteries you require, and with that, you can know how you are expected to wire your batteries. So conventionally, we have our batteries in 12 volts, 200 ah, or 12 volts, 150 ah. I don't think anything lesser than that is suitable for residential use. So if you have a 12 volt system and our inverter is a 24 volt system, or it uses a 24 volt input, it will definitely mean that you have to have two pieces of batteries and you have to wire those batteries in series. So series connection increases voltage while parallel connection increases current. So these are the things you need to know and advise your clients on what to actually do. So if you get a client that says he wants more backup time, that then means that you have to give him more AH. If you have a client that is really not interested in storage or in backup time, fine, your two units of batteries would definitely be okay. That way, you just wire it as 24 volts, 200 AH. The AH doesn't change. But if you have a client that needs more storage, you either have to give him 24 volts, 400 AH, 600 AH, and thereabout. But mind you have to be very careful when sizing your batteries. Once you start stacking it in parallel, in so much parallels, you also have to consider the charge current. So for a 24 volt system, I won't advise you have more than two stacks. What I mean is I won't advise you have more than 400 AH because anything above that places a strain on the batteries because your 24 volt inverters do not come with a high charging current. So the maximum charge current you can expect for a 2 kVA inverter should be I think 10 amps or 20 amps at max. I've not seen an inverter that allows you to charge more than that. A small inverter that allows you to charge more than that. So you have to size your battery and also appropriately and also consider the charge current and also consider your charging source, how long it's going to take to charge because increasing your backup power or means that you have to increase your charge time or your charge time increases. So I have here that series in when you wire in series, your current is constant while your voltage increases. When you wire in parallel, your current increases while your voltage remains the same. So for those that are joining, if there's anyone that's just joining now, I'll go back to where we had our previous um, load analysis, and you can see here that the total wattage for our client here was 2.3 kilowatts. Here we have here as 2.3 kilowatts. So let's assume this client wants the power. He wants the backup power for 8 hours daily, and this is without PV. He wants his inverter to be able to power these appliances for 8 hours. How you can to assist or to design your battery pack, you have to multiply the total power, the total consumption of this client times 8 hours, the time he needs the backup. So that gives us 18.4 kilowatt hours, which means that this is the energy he requires, or this is the energy the client requires for 8 hours, and this is what the client will consume in 8 hours. So for a 24 volt system, daily requirement in AH for the battery capacity is going to be the total energy demand divided by the system voltage. I've been talking about using a 2 volt 24, a 2 kVA 24 volt inverter system. So the daily requirement here, as in terms of AH hour that the client requires, is 700 Hi, Glory.
Oh,
Okay.
Please mute your mic,
So,
microphones, please. I'm still here. And no, please
can I proceed?
continue. Yes, please.
Hi, Glory. Can I proceed?
Yes, I'm here. Please continue.
Okay. There's so much background noise. I think you need to mute a lot of people's mics.
Yes, I've muted everyone now.
Okay. So, daily approximately 800 AH. So this is what is required in storage for this load and to power the load for 8 hours. Okay, so I have here that since you do not intend to discharge the battery beyond 50% depth of discharge, do I proceed?
Yes, you should. Whose mic is on? I'm trying to. There's somebody who I cannot mute here. If your mic is on, please mute it.
Okay, so since we do not intend to discharge the battery beyond 50% load depth of discharge, that will in essence double the battery bank. So because we want the battery to last and to serve the purpose and its lifetime, we have said that we will not discharge beyond 50% battery state of charge. The implication of that is that it increases the battery bank capacity because you're just using half of 100% of that battery bank. And then if the client also says that beyond 8 hours, he wants this to take for, let's say, 2 days, 2 days for like
Hello.
what that
Sorry.
means is
Anyone,
that
please hold on.
8 hours on day one.
Whose mic is on? Please turn off your mic. I have already muted everyone, but there's somebody whose mic is still on. I don't know who this is. Okay, I think I got it. Yes. Please continue now. Please, you can just repeat the last things you said in the last 2 minutes.
Okay,
Thank you.
so what I said here is that to allow a battery last long and to serve your client, you know this issue of a client says, I bought these batteries in January and by April they've already been damaged, they're not serving me any longer, and all of those stories. The best thing you can do is advise your clients not to discharge beyond 50%. So once they shouldn't drain the battery completely, advise your clients not to wait until the inverter goes off before he recharges. So these are the common things that damage the battery and cause sulfation. So it's best you advise the client, oh, when you see the battery this way, make sure you recharge immediately. With that, you're increasing the lifespan of that battery. But the implication is that that increases the storage hour that you would actually need. So you can see here that considering the 50% depth of discharge, it increases the the total storage here, which brings it up to 1,500 AH. And then going further, in battery sizing, we have what we call days of autonomy. This is DOA. What days of autonomy means is what that means is how long or for how many days do you want this battery to last without recharge. So let's say this client wants this inverter to last, or this storage to last him for 8 hours for 3 days. So day one he wants 8 hours, day two he wants 8 hours, day three he wants 8 hours. The implication of that is that his battery storage is definitely going to be increased. So depending on the days of autonomy this client is requesting for, that is what determines the storage as well. So this is also a factor. This is also a factor. So we have factors when considering battery sizing. We have our depth of discharge, which we'll consider. We also have the time, the backup time, which we consider as well. We also have the days of autonomy. Okay, so let's say what I have here is, so for this home that requires 8 hours of power for 2 days without recharge, we can say that if we're using 200 AH batteries, we can say we would need 14 or 15 units. If we're using 1150 amp hour batteries, we would require 20 units. I know this is actually a large capacity. So this is actually a large bank. So most commonly, what you would likely just consider would be depth of discharge to reduce the cost and the um and to also reduce your material cost and every other thing, and reduce the bank capacity you require. It's just best you advise based on depth of discharge, and you can consider days of autonomy if you have solar panels installed. It doesn't make sense to um, advise your client on days of autonomy when he doesn't have panels installed on his rooftop to constantly recharge the battery. So for a 24-volt system, to wire the to for a 24-volt system, we'll be wiring the batteries in twos. So we would have two batteries in series, and then we have 7 or 10 in parallel. So this is for 20 units. This is for the 20 units. You take the batteries in twos, in multiples of twos, and then you have it in series of 7 or 10. So in series of 10 we're going to have 14. In series of in series of 7 you would have 14. In series of 10 you're going to have 20. While for a 48-volt system, you will see here that for a 48-volt system, the parallel connection the power connection for a 48-volt system actually is lesser. So also, moving on to the PV sizing for this client. So let's consider that yes, the client is in Lagos, and for Lagos we have approximately 4 to 6 hours of peak sunshine depending on the season. It's actually seasonal, it's not fixed. So during your rainy season you have at most 5 hours. During the dry season, yeah, you can say that we have 6 hours of that. And assuming you're choosing a 25 325 watt solar panels, considering using 325 watt solar panels, you would have here that you would have to multiply the wattage of the panel times the peak time of sunshine, then times 0.6, which is the conversion factor. What the conversion factor means is that you are converting from DC to AC, and also you're passing through cables. There are going to be losses during your conversion time, during the time that the PV or the DC power travels into the charge controller, then that travels into the battery. So you have to keep the allowance just so that you can meet the energy demand of the client. So for the total energy demand of this client, which we saw earlier, this is his total power. This is the time in which he wants to have the backup. So that's what gives us 18.4 kilowatt hour. So to know the number of panels that are required, the total energy divided by the energy from each charge controller. So that brings us up up to 15 units. This home for 8 hours for one day, you need 15 units of solar panels. Anything below this, you definitely can't get 8 hours out of this. 8 hours of charge and discharge. This is like 8 hours of full charge. Like your batteries are fully charged. That is when you can have 8 hours. Now, if the client starts as discharging, please note that you won't have 8 hours because your battery is not fully charged and you're not even allowing it. You're discharging what is going in. So to have these 8 hours, you definitely have to charge fully. Your battery has to be fully charged. So we move on to the charge controller, the different types and how the charge controller basically works. So here I have that the charge controller is connected in between the battery and the solar array. The charge controller is what regulates the charge that comes into the battery. Sometimes when the sun is at its peak, the panels generate a very high voltage, and that voltage you can't use it on your electronic devices. And as we know, Nigeria, we use 220. One panel can give you like 45 volts. So depending on how it is being wired, you can have not you can have up to 1000 volts coming from your DC. And I'm not sure there's any DC appliance that uses 1000 volts. So you need a charge controller to regulate what is coming in from the solar panel. And also your charge controller prevents the battery from discharging. The charge controller prevents the battery from discharging back into the solar array when there is no sunlight. So since the battery can always serve as a source, you need a charge controller as a brake or as the protective device that prevents the feedback. So you can have just an electrical, or should I say solar design, that has just charge controllers is called a DC coupled system. So you can have one charge controller, you can have multiple charge controllers feeding just one system. Sometimes these multiple charge controllers can be smart charge controllers, or they can just be the common ones you can find in the market. And how to connect this charge controller is what determines how balanced your system is. For multiple charge controllers, it's not advisable to feed different banks with different charge controllers. So you can have like battery bank one, and then you connect a charge controller to a battery bank two. You connect that's not a balanced system. For a balanced system, all your charge controllers need to be connected to a bus bar. So I'm going to I have in further slides something showing how the balance of system works. So we have two types of charge controllers. We have the pulse width modulation and the MPPT, the maximum point tracking. The best and most preferred type of charge controller is the maximum point tracking. That's the MPPT. And charge controllers they charge in three stages. They charge at bulk, they charge at absorption, and they charge at float. So bulk is when your battery is probably totally drained. That is when the charge controller charges as bulk. And at bulk, the voltage is increased and the current remains constant. Then the charge controller moves to absorption. And at absorption, the current is increased and the voltage remains constant. While at float, both current and voltage remain constant. So you most likely see a charge controller charging at bulk early in the morning because of the discharge that has happened during the night time. So most charge controllers are always at bulk during the morning time. Then depending on the state of discharge, it can move to absorption or it can remain on bulk the entire day. or it can remain on bulb the entire day. So you can see here that solar charge controllers are rated and sized by the solar panel array current and system voltage. If you look at a solar panel, you see behind the rating of the solar panel, you see the wattage, you see the short circuit current, you see the open circuit voltage, you see the VMP, and you see the IMP. Yes, if I'm not mistaken. So these are the different parameters behind the behind the solar panel. But what is and what should be considered when sizing is the ISC and the VOC. The ISC is the short circuit current, which is the worst case scenario, the maximum that this panel can give out if there is a fault on the line. And definitely you do not want the faulty panel to actually destroy the charge controller. So we size with the worst case scenario. You size with the open circuit voltage and with the ISC. So I didn't include all of that here because that's kind of like advanced. I just assumed that was advanced. So I have here that since we're using 15 units of the 325 watts panel, which is what we got um yes here when we're sizing our PV. So we divided the client energy, we divided it by the energy produced by one charge controller and arrived at the fact that we need 15 units of charge, I mean of solar panels. So in order to size and to know the ampere of the charge controller, we have here that you multiply 325 by the number, then times 1.25, which is also the tolerance that we give for charge controllers because of temperature variation. Then you divide this by 48, which is the system voltage. If it is 24, you divide it by 24. If it's a 48 volt system, you divide it by 48. So this now gives us 126, approximately 130 amps, 130 amps charge, um, 130 amps. So for this part, it's kind of like tricky because you don't size charge controllers based on this alone. You also we can have a scenario where the client has already bought the charge controller and he has bought the panels and he's telling you to come and wire it up. At that point in time, you can't discard what the client has bought and say, oh, because you bought this thing, I can't size it. So sizing the charge controller is definitely both ways. And our training in April, you would have more details on how to actually size properly and the different ways, the different type of sizing that you can do. So for this case, when we have 130 amps, this is like an impossible figure for a charge controller. What this means is that you definitely have to use so much you definitely have to use a very big cable size to pass in 130 amps. And as we know, to minimize loss, energy or electricity is transmitted in high voltage and low current. So we'll apply that to the charge controller. So I say here that this 130 amps that we have gotten is actually so high. So we divide that by 3. So if you divide your current by 3, we have 43.3 amps, that's approximately 50 amps. That then means that your power your panel connection will be in series and parallel, because actually if you wire 15 solar panels in series, you're increasing the voltage, but the current remains the same. And since we do not want a low current, we want a substantial current, we are going to wire the wire the panels in parallel and in series. So if you're wiring these 15 panels in series, you can go 5 by 3. In that way, you don't have any remainder. So let's say if I had 14 units of um solar panels, I would go 7 in series, 2 in parallel. That gives me 14, and that closes out So if I have 10, I'll go 5 in series, 2 in parallel. So 15 means 5 in series, 3 in parallel. So if you wire your solar panels this way,
Hello, everyone. Are you still there? I think something has happened, and I think it has to.
Yes, I'm there. We can hear you, but we cannot see.
Yes, I'm here, but yeah, I'm here to Glory, but
Oh,
we can't see anyone.
We can't see the lecture again.
okay.
I
Yes.
can hear you.
Okay. Okay. Thank you.
You are welcome. Thank you for the job.
Okay. So, I think the network of our speaker is out again. I think, have we been following all this while?
Yes.
Okay.
Yes.
Yes, we are following.
Okay. Thank
And
you.
I'm about to move the speaker again.
Yes, please do. Please do that. Thank you. I'm also about to mute.
Yeah, let everybody move the speaker.
Yes. Okay. Thank you guys for muting your speakers. The issue is really because of poor network. We tested this mic before starting, and it was working well. Some of you were here at the time we started at 7:45, so you could see that we were trying to test the mic, and it was all good then. So basically, what we were doing here today, whilst we're waiting for our speaker to come back online, is basically how to size up a system for a home. People can ask, how can I size up a system for a 3-bedroom flat? How do I know how many solar panels to use? So that is what she has explained here today. And I'm trying now to see if I can get her on the phone. I want to see if I can get our speaker back on phone. She should be joining us very soon. Enobong, have you joined now? I can see that you joined back in. Okay. So basically, that was it. I'm glad that despite the voice, many of us were still able to hear. Right now, I want you to begin to put your questions together. Questions around batteries, inverters, or whatever it is you heard during the webinar, during the slides that you would like to ask about. Some of you were not hearing properly, so whatever it is that you want to clarify, you can begin putting that together so that we can just shoot straight up when the speaker gets back. Miss Enobong, are you here now? I'm sorry, it looks like I'm in a noisy place. Can you also hear me? I think you can. Okay, because
Yes, Glory, we can hear you.
all right, thank you.
I can hear you clearly.
Yeah.
Loud and clear.
And the question, are we asking by voice or we are typing to the
No,
chat?
you're going to type it. So it's better you start typing it out now. Yes. Type your question out now so that we can shoot when she comes back. This is a very interesting. Enobong, how far? Are you still here? Okay, so try to share your screen again as soon as you put it together. Okay. So people, this is a very interesting one for me because when I joined the energy sector, I am not an engineer, but I took a course just like some of you here are RETI alumni. Some of you here have taken a course from RETI. Same way I took a course and I tried to understand the course that I took was even for a bigger, how to size panels, inverters, batteries for a bigger system, like for a commercial one. And I knew that this was an area that I really, really wanted to understand. So I'm happy that some of you said you understood what she said. Already, when you know that your total client need is like 3,000 watts, you already know that that is a 3 kVA or 3,000 VA. So basically, you know that you're going to buy a 3 kVA inverter when you have sized up your client's electrical requirements and it is a total of 3,000 watts. Let us say it's a total of 3,200 watts. So now you know that you need to get a 3.5 kVA. And whatever battery size you get, you must always okay, yes. Sorry about all the interruptions. Sorry about all the interruptions. When you are sizing your system, always bear in mind that your battery must never discharge at 100%, right? That enables the battery to last for longer. So, Miss Enobo, when you get in, please let me know. And like you shared in some of the calculations, you could see the formula that you need to calculate before you can get the exact number of panels you can use for that season. So these things really play a role. And there was something I forgot to say in my introduction about the fact that there is a big opportunity right now in this sector. I'm not saying that it's like make money quick rich kind of thing. No, it's not a make money quick rich kind of a scheme like MMM or all those other ones. No, but it is an industry that is emerging. Before long, there'll be solar panels on everybody's roofs, and that creates a lot of opportunities for including maintenance, repairs, servicing, installation, design. So some of you who made it for this training, I give you kudos, because now you're trying to get ready for something that is going to be a big area in the future. Some people say solar is expensive. The reason it's so is because there's still a lot of opportunities to join in now. So, Enobong, are you ready now?
And give me some minutes, please.
I want you all to take it very serious what you're learning here today. Did you know that 93 million Nigerians, 93 million out of around 180, it's the number of people without access to a grid connection. I'm not talking about the number of people that don't have NEPA. I know most of you, even people here that are not from Nigeria, most of the people without access to electricity, you know, is mainly because they don't have light from the local distribution company. So the light comes on and goes. So there is outages from time to time. Sometimes you have 12 hours outage in a day. I'm talking about the people who are not even connected to the grid at all. There's no electricity pole on their village. 93 million. Now, you see, when I heard that, it makes me think really the amount of opportunity there is. I just returned from South Africa, where I was selected to attend the Open Africa Power, and my eyes were open to the opportunities. We're about to launch a business course, an online course, where we're going to even be explaining more how you can sell electricity, not just how you can install panels, but how can you even invest into bigger opportunities, including how to sell electricity and connect to the grid. So these and many more are all the things we're going to be sharing with everyone who is signed up under our Renewable Energy Connect. We have a new platform, Renewable Energy Engineers and Entrepreneurs Connect, REN Connect. Some of you are on that Telegram platform. That is a way that we want to bring entrepreneurs together, offering you opportunities to learn something that you have been going through that you don't know. One of the days recently on our Telegram group, somebody was making inquiry about how to calculate the peak sun hours. So, I mean, from time to time, we try to ask the participant, what is a problem area you're facing? The reason we do that is because we want to address that in a webinar, or we want to bring in an expert to talk to you there on the group. The goal of this whole thing is that there is a lot that is accessible as a young person trying to make a mark in the field of energy. Thank you. Are you ready now?
Yes, can you see my screen?
Yes, please.
Okay, sorry guys about that. Thank you, Glory, for backing me up. Okay, so I think the last thing I said was how these panels would be wired. So I said that for 15 units, can you mute? For 15 units, you're going to wire 5 in series and 3 in parallel. So this would definitely come up to this might come up to 50, but I doubt you're going to have it. What you have is 20, and it's not so good to size your charge controller so closely because of the variation in sunlight and irradiation. So here is an installation at a client's home, and this is what I would
call, or what is called, the balance of systems. So if you look at the picture that you have here, you have an inverter, you have a charge controller, and then you have these conduit boxes that contain circuit breakers. Then you have a stabilizer, then the battery itself. With this, you can see that the system is actually balanced. Balanced in terms that there's protection for it. If anything happens, you have the circuit breaker strip off, and the stabilizer there is to regulate the voltage that goes into the inverter. So if the voltage is too low, it cuts off. If the voltage is too high, it cuts off. So this system is pretty much balanced. So the balance of system um, includes components of a photovoltaic system, with exception to the PV, that's the solar panels. So the balance of system here is, you can say, the trunking, the batteries, the battery rack, the cables as well, the battery, the charge controller screen, and every other thing here, the stabilizer, the changeover, the switch, the knife switch, everything here. Without all of this, if there is a fault on the system, your inverter is going to be damaged. I've had so many people say that small rain that fell, the inverter got burnt. Any lightning that occurs, the inverter gets damaged. So to avoid all of that, it's essential that you have protection on both the AC part and the DC. So if you can see, let me zoom in a bit. You can see that here we have where the DC is connected. That means the battery. You can see that there's a breaker here. Where the charge controller goes into the system, there's a breaker. Where the where the inverter feeds the load, there's a breaker, because anything can happen. You don't want the system shutting down or the inverters being destroyed in case of lightning, in case of rain. And yes, we're actually in rainy season. Whether in rainy season or not, it is very, very important to ensure that your system is balanced. So protection. Here is a picture of what protection looks like. So up there we have the surge protector, we have the circuit breakers, both AC and DC. And please ensure to always earth all your installations. Without the earthing, once there's thunder, and that for high-rise buildings are more prone to lightning destruction. So if your client has a high-rise building, if he has a bungalow, whatever type of building it has, please always ensure to earth your PV. How do you earth your PV? Since your solar panels are connected to aluminum rails, those aluminum rails serve as conductors. So you wire those aluminum rails down to the earth. That is definitely going to cause any surge that might want to come in from the PV, because whenever there's lightning, the solar panels, they receive charge, and they want to send that quick charge down into the batteries, and that is definitely going to blow out your charge controller or your inverter, because they are all wired together. So it will definitely blow off your board. So to avoid that, please always earth your devices. Please always earth the PV installation, and also always earth even the inverters in-house. Let everything go down into the earth, and also always test the earthing of every location. How to test the earthing is, you put your multimeter on the neutral, either output or input, and then you put your one probe on the neutral, one probe on earth. Anything above 5 volts means that you need to fortify the earthing of that facility, which means that the earthing is weak, which means that if there is any cause of lightning, most definitely your equipment will be damaged. So always try, as a professional in this field, to practice good engineering practices, or to ensure that you follow engineering practices, which entails you doing earthing all your devices, which entails protection as well. So to protect these devices, you can either protect with circuit breakers, fuses, surge protector, or lightning arrestor, depending on your client and the facility. So if you go to a facility and there's no lightning arrestors,
Hello, Enoba,
the
can
the
you still hear?
inverters pack up.
Okay.
Sorry.
Oh, okay. We lost you for a while. We weren't hearing.
Okay, please, what was the last thing you heard so I could back up?
Don't worry. Just continue with the last 30
Okay.
seconds.
Okay. So what I said here is that ensure that your devices or your client's devices are protected on the AC parts and on the DC parts. So if you go to a facility and there's no lightning arrestor, please advise the client. If the earthing is poor, make sure you advise the clients. If they complain, your installation cost is so expensive, let them know that without protection, they won't receive warranty, or without protection, these devices are going to pack up in the slightest rain or with the slightest thunder. So that is all. That's all I have to present here. I hope everyone has learned one or two things concerning PV sizing, battery sizing. I hope everyone sees the need to follow engineering practices. I hope everyone sees the need to ensure that their inverter systems are balanced. Thank you very much. Glory can take over.
Wow. Thank you so much, Engineer Nobon. We really, really appreciate this, and it's been a great time here today. We apologize deeply for the issues with the audio. Your second audio was really, really much better, Miss Enobong.
Oh, okay.
You started using another system, or I don't know what happened.
Probably the network just got better.
So good evening. I'm not hearing. It's actually a wonderful night. I don't know if anybody's hearing me.
Yep. Please send anything you have to say via chat.
Yes, sir.
If you have a question, please send it via chat. I will read out your question to the speaker. Okay, thank you. So there's a couple of questions for you. Like I said, we apologize for the problems with the audio. I want to read out the first question. The first question is from Mr. Emmanuel Fasen. So he
Okay.
said, yes. Sorry, I'm trying to get to it. He said, okay, somebody said, Austin Allens, first of all, said, what informed your choice of a 24-volt system voltage? I think he was trying to refer to when you were talking about batteries or so. I'm not sure. So you can clarify, Mr. Austin. You can clarify your question. But he said, and I'm sure you can look at you are looking at the chat now. Enobong, are you?
Yes.
You can
Yes.
see things that people asked. Yeah. So do you want to attend to that one first? Then we can read out the other ones.
Yeah, I just need to be sure. 24 volt on the battery or on the inverter system. Can he please specify which it is?
Yeah. So while we're waiting for him, I'll read the next question. I'll read out the next question for you. It says, apologies, I'm trying to get to it. So someone now said, on solar, okay, so I'm going to share a link to answer that question. On solar panels, I would like a brief stuff on monocrystalline and polycrystalline panels. Do you have anything to say to that? Quickly, because of time, we're over an hour already.
Okay, what I have to say is that monocrystalline works better in cold regions, while polycrystalline is most suitable for Africa and temperate regions.
Okay. Why is that so, please?
Because of how the cells are designed. So the mono cells are kind of like compact together. And with our hot temperature, when the sun strikes on the solar panel, what we have is electron movement. So the way the monocrystalline is actually compacted together, it doesn't allow these electrons perform very well when the weather is really, really hot compared to the polycrystalline.
Okay.
That's, yes, we have full movement of electrons.
All right, that is very clear. Thank you very much. I'll also share a resource material for that question. Then he says some calculation that you used, whilst you were talking, used the short circuit rating of solar panel to size the charge controller as against the formula used here. Please, could you clarify? I don't know if you read that as well. Yeah.
Yes, I can see that. So if you remember clearly, I said something about different ways of sizing the a charge controller. You could size it with the wattage and then getting the current and dividing. You could also size it with the ISC. So I could I could clarify further by saying that I didn't want to go into so much details. I just wanted to give a generic and an easy to size method.
Okay. Okay. Thank you very much. And then the next one says, I have a somebody wrote me privately. He said, I have a size 15 battery to 180 volts inverter. What will be the actual charge controller and PC to be used? I'm not sure I even understand that question.
I don't understand that as well.
Yes, it's very, very it's confusing. You have a size 15 battery to 180 volts inverter.
No.
Okay.
Hello, can you hear me?
Yes, quickly, please.
Yes, I said I have sized.
Okay, sized.
Have
Okay.
size. Oh, okay.
Yes, I have sized in series for 180 volts inverter
Okay.
with just to be using NEPA light as charge to charge the inverter. So I wanted to know if I want to use PV, what will be the charge controller and what will be the number of area we use?
Thank you.
Okay. Please take my number from the end of the slide and get in touch with me. I can't do that much
Okay,
now. We're short on time.
Yes.
no problem.
Okay. And then the next one says, okay, sorry, the next one says, since you considered power factor initially, why did you calculate amp hour as amp hour equals to kilowatt hour divided by system volts and not AH equals to VAH system divided by system volts?
I'm coming.
Yeah.
Okay. So I believe this calculation, I'm sorry, I've forgotten why I made this calculation, but when you're sizing for when you're doing the sizing, you actually size or you actually make your calculations in wattage. Then at the end of the calculation, that is when you convert to to kVA. So I don't know if this answers the question because I'm not so clear on what part. He said when considering power factor, you did calculation in AH. Power factor, the power factor has nothing to do with the battery size. Please, could you clarify? Whoever asked this question, please, could you clarify? Because I can't really place where this question is coming from or what slide the question is coming from.
Okay, so please let's move on to the next question. Most of these things will be shared on the Telegram group afterwards.
Okay, sure.
So that those people can clarify their question if they are on the Telegram group. Yeah, she's also on the
Definitely.
Telegram group as well, people. So please, can you read out the next question, please? Thank you.
I don't think we just need more clarification on the conversion factor for solar panel. So I think I'll address all of this on the Telegram group. So please post your questions there.
Yes. So the ones that she can address now, because we don't want our replay to be so long. This guy, have you answered this one? The guy said, in case the client, please, can you mute your microphones, please, guys? I'm trying to read out the questions and I can't do that right now.
I can't see. What question?
Okay, the question I'm talking about is this one. Sorry, I'm about to read it out to you.
Okay.
I'm finding it difficult to see the chat room right now. Okay, yes, I got it. It says, in case a client needs his system to run for 24 hours, do you multiply the total watts of each appliances by 24 hours?
No, you would not. What you would do is you multiply the total. Okay, if the client needs all his appliances to run for 24 hours, yes, you would multiply each appliance by 24 hours so that you can get the energy each appliance will be drawing from your system.
Yes.
Or you can as well just add.
Hello? Are you still there?
Did you get that?
No, your voice went off completely for recently.
Okay, so I said that since all the loads are to be running equally for 24 hours, you can add all of the loads and multiply by 24, or you go individually. I think you will have the same end results.
Okay, that is very clear. Then someone says power factor. How did you get that? Power factor is usually a constant. So please answer him.
You said it. So
Yes,
yeah, power factor is a constant and it varies on the different types of appliances. Like for inductive devices, you have a different power factor, but most generally is a constant of 0.8 to 0.9 to 1. It doesn't really change.
Yes. Someone else says, can you explain how the solar panel can be protected apart from putting breaker in between the PV and the charge controller?
Yes, by earthing the solar panels, I think I made mention of that.
Yeah,
you have to ground your solar panels so that if there's any device or if there's any thunder, it doesn't send surge power to your other devices. And also another way of protecting the solar panel is by ensuring that the resistor, if you look at the solar panels, there's something behind it. It has a diode there. So ensure that diode is intact, because without that diode, your solar panels are going to be destroyed. Your solar panels are going to be moving, like the power flow is going to move reverse. So that diode allows the power to flow in just one direction. So ensure that diode is intact for every solar panel you purchase, and also at your solar panels.
Okay, yeah, so we have the guy. The guy have gotten back to us who asked a question on the 24 volts. So he clarifies that it's on the battery.
I can't see that. Okay, which question? So, the one that says considering power factor initially, why did you calculate AH?
No, is that the one you said you will get back to later on the group? That person? So no,
I can't remember.
This person said, what informed your choice of a 24 volt system voltage?
Oh, okay.
The battery, yeah.
Okay, specifying on the battery. The battery connection is dependent on the voltage of the inverter, the DC input voltage of the inverter. And I was just using, for that home, I was using a 3.5. So sometimes you have 3.5 in 24 volts. Sometimes you have 3.5 in 48 volts. So depending on on the rating of your inverter, that's what determines how you wire your system. So for a 24 volts system, you definitely have to put two 12 volts in series. For 48, you have to put 4 12 volts in series.
All right, that is very clear. And then someone says, this person says, what is the peak sun hours used in Texas states? That resource is very easily available on the internet. So I will share that. I will share that on the Telegram group. Another person says, there's a question that I missed. I'm trying to scroll up to find it. I need more clarification on selection of conversion factor for solar panel.
I think each solar panel comes with its data sheet. This information, you can find it on the data sheet of your solar panel. So it shows you the efficiency, it shows you at what it shows you the conversion factor as well. So it's highly dependent, but plus or minus, you should always just leave allowance when you're sizing your charge controller, because if you don't have clear information, just use 1.25.
Okay. I hope that is clear. So do we have any more questions? I want to look through and see. When you have multiplied all the appliances by 8 hours from your examples, will your appliances run all day at full charge?
No, when you mean all day, if you're referring to all day as 24 hours, your appliances will not run for 24 hours. The 8 hours is the time in which your appliances are actually going to run for. So your appliances would run for 8 hours. This system is sized to power appliances for 8 hours and not for the entire day.
All right. So let me just take the last question and we can go. So I think that's all. We will give room for one more quick question. If someone can ask now, you can unmute.
Please, can I ask that quick question, please?
Yes, quick
Hello,
question.
can I ask the quick question, please?
Yes.
Okay. Hello, am I on?
We can hear you.
Hello?
Hello, am I on?
Yes.
Yes.
Hello, I cannot hear anybody. Okay. Please, if I'm sizing for like a 6 hours design,
Okay.
can you hear me? If I'm sizing for like a 6 hour design, a very small design of like 400 watts, and the client is not connected to grid, you want to be charging, and it's a shop. It's not even the house that you use at night. You want to be charging why, like you resume to the office at 8, and they want to be using the solar panel. I mean, you want to be charging and be using it as well.
Yes.
Now, if I design my battery, maybe I have a 200 amp hour battery and a 600 watts panel. Then when I know that this one I'm not charging it. I'm not charging it to be used later. How will I
Yeah.
now? How will I make this possible? Do I need to multiply the wattage? Like if I've calculated that 600 watts will give me the 6 hours. So how will I make this possible? Why they will be consuming the power and I will be charging and they will still get it in the 6 hours and I won't damage my battery.
Let me ask, are you asking on how you would size your PV or your backup? Because for a shop, you actually don't need so much backup. So if your system is a 24-volt system, I would advise you just leave it at one string, one series. You don't have to parallel it because it's a shop, you don't need storage. So just clarify, are you referring to your PV size?
Yes, I'm referring to the PV size that we charge. Normally if I calculated like maybe four 200 watts, like 800 watts will give me
Mm-hmm.
that 6 hours.
Sorry, I can't hear you.
But
Okay, now we just have. Oh
now,
my God.
I can't hear that.
Please, can you ask this question on the Telegram group? We have to round up now. Are you on the Telegram group? I think. Oh my God. So his network is poor, so nobody can hear.
Okay, so just
Yeah. Are you
I
still
can't
here?
see his. Yes, I'm still here, but I can't see his name. If you can take his name so that we
Yes.
could check.
I don't know him either, so he can reach out on the Telegram group, please. So in the absence of no do you want to play
Most of
video?
you will be consuming and be charging altogether.
Oh my
Would I
God.
need to Telegram group? I
Hello,
would
sir.
have that.
Yes, hello, sir. I think your network is really bad. Nobody heard your question at all. Your voice was cracking. So if you're on the Telegram group, please, the engineer is going to be there to answer this question. Kindly type in your question neatly on the Telegram group so that she can answer it properly because we didn't hear you at all. Okay, is that okay? So thank you very much, everyone. If you're not on the group already, please go and ask your questions on the group now so that we can, tidy this up neatly. Thank you for everyone that joined. Do you have any last words? Enable.
No, not really. Just to ask that I hope the link for the Telegram group is in the message box, so we don't lose out on the questions.
Exactly.
And also, I want to actually thank everyone for joining. It's really, really encouraging to see that there are lots of people that are interested in actually doing the right thing in the solar industry. Thank you so much for joining in.
So everyone, we have a training coming up on 13th April. This is what we're going to do on the training, a detailed training on solar PV design, sizing, installation, advanced practical installation. We're providing accommodation for everyone who is coming from distant places. Now, this training is in Lagos State and it's for 1 week. We host all the participants at our facility. Everyone has to arrive there on a Sunday and leave back on the Monday, full 7 days at a stretch. So if you want more information on that, you can call the number that I've already shared in the chat box. And I've now sent you guys, I have now just sent the link for the Telegram. Please come there with your questions. I'm aware that many of you still have some more questions, but we can't take it all right now because our replay is getting too long. So call this number on the screen right now for more information about our training. And also, Ms. Enobong is going to be on the Telegram group to answer more questions. So this is the number to call for inquiries about our training. Thank you everyone for joining us. And we have come to the end of this webinar. Thank you. Oh my God.
Thank you, Glory. Thank you, Enobong.
So
Thank you very much. Stay safe, guys.
Bye. Thanks.
Bye-bye.
Bye. Good night.
Good night. Thank you.
I actually enjoyed the training.
Thank you for the
May
feedback.
God
Are you on the
bless you
Telegram group?
guys. Thank you. Hope to see you. Yes, I'm on the.
Okay, good.
And I'll
So
ask my question on the Telegram group.
no problem.
Okay.
So do that right away. Thank you.
Hopefully, after the whole thing, I believe God will help us and clear all this pandemic, and we'll see in April by God's grace.
All right, guys. Thank you so much for your comments. Bye, guys.
Have a good night.
You too. I'm trying to end the meeting. Are you still here? No, she's gone.